X299, isn't that old news? Isn't there X399 now? Well, not so fast. X299 is Intel's platform, X399 is AMD's platform. Not confusing at all, right? This video is about the ASRock X299 Taichi, and my experience is putting a system together with it and testing Linux on it and checking it out basically as an everyman X299 board. ASRock really has done something interesting with the Taichi line, all the way back to the very first Taichi motherboard that they came out with, which is sort of everything that you need and nothing that you don't. That's kind of the philosophy, finding a balance, I guess, hence the name Taichi, not chai tea. It does actually pretty much strike the balance for X299, but it gives you some premium bells and whistles. For one, it's got dual Intel gigabit NICs. I would have liked to have seen maybe an Aquantia 10 gig NIC, but for the price point that this motherboard is at, that's maybe a big ask, because that would add a lot to the price. And hey, you've got the PCI Express lanes if you get the appropriate Intel CPU, so you can, you just add an add-in card. This motherboard, like all X299 motherboards, supports everything from the 4-core, 4-thread Kaby Lake i5 in the socket 2066 variant, all the way up to stuff that Intel hasn't even come out yet with the time of this video, the 18-core behemoth monster. As of the time of this video, you can get the 10-core Intel 7900X and maybe also the 2.9 gigahertz base clock CPU that's going to be 12 cores from Intel for the X299 platform. But, the $1,000 10-core CPU, I think it would be my recommendation if you're going to build a board with this. Maybe the 8-core. The 8-core CPU is around 600, 650 US, something like that. The 10-core is around 1,000 US. Those are really high-end CPUs. Those CPUs really, honestly, not really for gamers. It's a lot of cores would be for content creators, people that need a lot of CPU, people that are doing maybe CAD and professional work where it doesn't quite rise to the level of a true workstation platform with error correcting memory support and higher end features like that. That said, the $1,000 CPU does have 44 PCI Express lanes, and the $650 CPU has 28 PCI Express lanes, so it's kind of a differentiator there. How do you know how many CPU PCI Express lanes you need? Well, depends on how many peripherals you're going to run. You're going to run a lot of graphics cards with a lot of PCI Express add-in cards like the 10 gig NIC. Well, you're going to need more PCI Express lanes. The Kaby Lake CPUs only have 16 PCI Express lanes. Your GPU wants 16 PCI Express lanes, but it will work with 8. So it's like 2 GPUs, basically you're out of lanes. But I'm getting a little ahead of myself just talking about the X299 platform in general. First, let's take a tour of the board and give you all the information that you can get by reading the box. But it's cool, you don't like reading, I understand. It's cool. We'll go through the features that are on the box first. Let's start with the top edge of the board, which is pretty Spartan. You've got the one 8-pin power connector. Now that tells me that the CPU power delivery system on this motherboard, it is a 13-phase power delivery system, but 13-phase, that's kind of weird. What is to do with that? Well, the power delivery system is a little different between Kaby Lake and Skylake X, the Kaby Lake X CPU and the Skylake X CPU. Because the power delivery system is a little different between the CPUs, there is a little bit of redundant circuitry that motherboard manufacturers are saddled with when they're having to cope with Kaby Lake on this platform. So the power delivery system on this motherboard with the single connector, the absolute maximum wattage that type of connector, the type of 8-pin connector supports, where you've got the 4 12-volt power rails, is about 400 watts. And that's before things start melting. Really, the safe limit is probably just over 300 watts, 350 watts, something like that, and that's pushing it. And that kind of makes sense because we're talking about 140, maybe 165, maybe that's not really been super finalized, watts for your thermal design power of your CPU. So if you're going from 140 to 250, that's over 100 watts of overclock. So I think it's perfectly reasonable that, for the type of reasonable overclocks that you might be doing, that supporting a CPU TDP of around 250 watts is reasonable. So 8-pin, again, giving you what you need and nothing what you don't. I think the 8-pin power connector is reasonable. The real question is, how well does it overclock? And we'll get to that. Then we've got 2 4-pin fan headers. Now, this motherboard actually has a total of 5 4-pin fan headers that support a mix of 1 amp power delivery and 1.5 amp power delivery. 4 of the 6 support 3 or 4-pin fans. The other 2 are PWM only. The CPU header is one of those, which kind of makes sense because, hey, if you're running a 3-pin, chances are it's a water pump, and so you don't want speed control on the water pump. Probably you want the water pump running, full speed all the time. And for a 4-pin, you probably want, PWM control. But there is also a 1.5 amp water pump header that does give you 3 or 4-pin control. So if you have one of the water pumps that has the DC control from a 3-pin, you can use that on the water pump header, and it'll also give you 1.5 amps. So you've got options. Rounding the edge of the motherboard, we've got our first RGB header, a 24-pin CPU power connector, and our first USB 3.0, that's USB 3.1 Gen 1 front panel connector. Then we've got 10 SATA 6 gigabit per second ports. Then just below the SATA ports, we've got our chassis fan, our first 4-pin chassis fan header, and then we've got a bevy of front panel connections. So this is for system panel or front panel connections, power LED, speaker reset, that sort of thing. Also at the bottom edge of the motherboard, we've got another 3-pin, 4-pin fan connector. This is also a water pump connector, which means this connector will deliver up to 1.5 amps. Next to that, you can see our BIOS A and BIOS B. It does also support flashing the BIOS through USB. BIOS flashback, as it calls it on the back of the box, means that, when Intel finally does come out with that 18-core CPU, if you adopt that and you happen to get old stock on one of these motherboards that has a UEFI that doesn't support the CPU, you can use that functionality to upgrade the UEFI on the motherboard to support that CPU, where it might not post with that CPU because the CPU is too new. That gives you the option to upgrade the UEFI without even having to have one of the older CPUs. Then we've got 2 USB 2.0 headers for internal peripherals or breakout headers or anything like that you might use, a TPM header connector if you're using TPM modules, and then a Thunderbolt header in case you're using a Thunderbolt add-in card. Next to that, we've got a 4-pin RGB LED header strip, and then a clear CMOS jumper, and then our isolated front panel audio connections. Now, just below the CPU socket near one of the banks of memory is another 4-pin fan header. You can use this for a rear fan or something like that. And then opposite that, you've got the Intel Vrock module. What the heck is a Vrock module? Well, Intel's kind of painted itself into a corner with M.2 RAID, and so you, the consumer, should totally pay Intel extra money for the corner that it's painted itself into with Vrock. Now, I'm being a little hard on Intel. Let me tell you what it does. So, see all these M.2 slots? This motherboard has 3 M.2 slots, 2 80mm, 1 110mm M.2 slot. It's pretty great. All 3 of those M.2s go through the PCH. The PCH is connected to the CPU with a DMI 3.0 interface, which is a maximum of 32 gigabits, 4 gigabytes per second. So if you're going to use M.2 RAID on this, the absolute maximum that RAID array is going to go is 4 gigabytes per second read and write. So seems like a bottleneck when you're talking about the Samsung 960 Pro, which can do that. So Intel has an option for you. You can plug a module into that header, and that will let you use some of the PCI Express lanes for your M.2 devices. Now, you're still going to need an adapter to plug those M.2s into a PCI Express expansion slot. That is not included with the Vrock module, but when you do that, the M.2s will be supported off of the PCI Express lanes instead of the DMI lanes, so that removes the DMI bottleneck. Maybe it's helpful with a block diagram of the system. Basically, all these quote-unquote low-speed peripherals are gated through the PCH. That's not actually a bad thing. That's good design. You should take all of the low-speed peripherals and not give them tons and tons of bandwidth, because that's wasteful of your PCI Express resources. The problem is that we've transitioned our NVMe devices from, being somewhat faster than SATA and significantly faster than SATA to, oh my gosh, a single gumstick sized M.2 can actually deliver over 3 gigabytes per second read. You talk about Optane, assuming that Intel made consumer M.2 Optanes with a reasonable capacity. They don't at the time of this video. You can only get 16 or 32 gigabytes that you use for acceleration, but one supposes that the business end of Intel will sort of say, hey, maybe we should actually make some reasonable capacity Optane, because it actually is a really good, really interesting technology. The enterprise is going to buy the crap out of Optane drive. So with this Vrock module, you buy this thing and it unlocks functionality. It's just a software unlock on your motherboard. The module doesn't actually do anything. However, if you buy Intel Fultondale NVMe SSDs, then you get the RAID 0 functionality for free. I don't know about that. Okay, sounds good. You can buy another more expensive module and get more RAID functionality, but again, you need an adapter, because you can't actually use the M.2. Well, you can, it'll just be bottleneck, because if you use the M.2s that are on the motherboard, it's not going to magically unplug those connections from the PCH and plug them into the PCI Express lanes on the CPU. No motherboard that I've seen for X299 yet does that. So it's really just a needlessly complicated situation on X299, and if you're just like, I just wanted to know what features the motherboard has, I don't really care about these features. If you're buying a machine that's this high end, that has 10 cores, and you're really going to put those cores to use, and you're thinking about RAID and NVMe RAID, you've got a little bit more homework to do, I'm sorry, because understanding the situation will be really important for squeezing the maximum performance out of whatever it is that you're building. Okay, let's talk about the PCI Express slots on this motherboard. We're there, finally. For the PCI Express lane configuration on this, if you really are going to run a lot of PCI Express peripherals, or you might in the future, you definitely should consult the manual, because the manual from ASRock will give you a diagram of which CPU, 28 lanes maps to these slots enabled, 44 lanes maps to these enabled, but I'm going to try to do it real quick in this video and have it make sense. So if you get the 44 lane CPU, and you get the fully populated motherboard where you're using all 4 of these by 16 slots, the PCI Express lane configuration is going to be by 8, by 8, by 16, by 8. Yeah, that's kind of weird. So if you're running peripherals like video capture cards or machine learning accelerator cards, or Xeon Phi cards or whatever, you'll want to be sure that you put your graphics card in the 3rd slot when you're using all 4 lanes, because only the 3rd slot is guaranteed to be by 16 on that platform. Now, if you're not running all the peripherals, then the top slot will also be by 16. So, the other configuration will be by 16, by 8, by 16, by 0. So the bottom slot ends up being not used, or you shouldn't populate the bottom slot if you want the configuration to be by 16, by 8, by 16, or by 16 you don't have a card, and by 16 in the case of SLI, because that'll give your graphics cards the most bandwidth possible. Now, if you're running 28 lanes, there's no way to give both of your graphics cards by 16. That makes sense. The math checks out. But you're in a situation where it's like, well, wait a minute, there's not enough PCI Express lanes for everybody. Yes, that's right. So in that situation, it's going to be by 16, by 0, by 8, by 0, or by 8, by 0, by 8, by 8. So the usable slots on a 28 lane CPU, assuming that you're using all of them, would be the top one, skip one, and then the next 2. So that kind of makes sense from a peripheral standpoint, because if you've got 2 graphics cards in there, they'll be at by 8, and then you've got another expansion slot that you could use for a video capture device or something like that, but there's not enough clearance to use, a double height card in that 3rd slot or whatever. Now, it's worth mentioning that if you're using a Kaby Lake CPU, things get even weirder, because the Kaby Lake CPU only has 16 PCI Express lanes, and on, say, like a Z170 or Z270 motherboard, you could actually run a graphics card at, by 8 by 8 on that motherboard. This motherboard, you can't do it. It's by 8, by 0, by 4, by 0. The other 4 PCI Express lanes are used elsewhere for other connectivity. So you can't even run by 8 with Kaby Lake on X299. Intel really does not appreciate it when reviewers say that Kaby Lake X on X299 does not make any sense, but it does not make any sense. My personal opinion is the reason they did that is so that they could say, oh, you can, do 5 gigahertz or 5.5 gigahertz. You can have the top end, single thread performance with the version of the 7700K that is socketed for X299, because when you increase the core count, it's really hard to get those ridiculous single threads clock speeds. So, it is what it is. All right, for the rear I/O on this motherboard, we've got 2 USB 2.0 ports, a combo PS2 mouse and keyboard port, a CMOS reset button. Then this is our wireless solution, an Intel 802.11 AC wireless solution connector. Then we've got our BIOS flashback button. This is the functionality I was talking about before, where you can hit the button and upgrade the UEFI in the system even when it's off, even if you have a CPU that's not supported, even if it won't post. Then you've got 2 USB 3.0, that's USB 3.1 Gen 1, the protocol connectors, and your first of 2 Intel gigabit NICs. Then we've got the other Intel gigabit NIC. One of those is an i219, the other one's an i211 AT. Then we've got our USB 3.1 Gen 2 10 gigabit per second port provided by an ASMedia controller. Then we've got our audio connections, including an optical SPDIF port. This is an implementation of the Realtek ALC 1220, which ASRock calls Purity Sound 4, and it does also support DTS Connect. So if you're doing stuff with, DTS Connect format audio, totally works, totally is fine. Oh, and the ASMedia USB 3.1 Gen 2 controller is an ASMedia 3142. Last thing about the physical thing, what's in the box? Well, you get the IO Shield cover, the driver CD, the manual, the software installation manual, which gives you some information about the stuff that's in the BIOS, but not a lot of info. You get both a high-speed bridge and a 3-way SLI connector in case you're running slightly older graphics cards. You get 4 SATA 6 gigabit per second connectors, the ASRock Taichi postcard. Look at that, it's a nice postcard. And then you get 2 rubber duck antennas. Again, everything that you need, nothing that you don't. Although I would like to see just a few bucks more spent on the wireless antenna solutions, because it's really not great having the wireless antennas sticking out the back of the computer. I'd much rather have a movable antenna on a wire. I feel like that people get a lot more mileage out of that than the antennas at the back of the case. That said, you can order them. I mean, you can go on Amazon or eBay or whatever and order better Wi-Fi antennas if you're having signal problems. But you know, the Intel 802.11 AC wireless solution is a good one. It is not an inexpensive option to add to motherboards. So it is nice that ASRock used the good quality Intel NICs and the good quality Intel wireless adapter. So, you know, good job. Now, overclock ability. You may have detected some hesitation talking about the VRM solution on the X299 Taichi. And again, I think ASRock is walking a really fine line here between, you know, not overbuilding the VRM and also not really paying attention to Intel's, you know, super optimistic. I mean, 140 watt TDP is almost borderline, like, just no. You can get a ton of performance, a ton more performance out of your standard 7900X, not even really overclocking, just changing the long and short power duration limits on the CPU. You've still got thermal protection, so if the CPU gets really hot, it'll downclock. But the 7900 series, like this Skylake X series of CPUs from Intel, they drink power and they run hot. There is just no way around it. And so with the Taichi, you know, historically, ASRock has given you overclock ability, and they've also done that here. This has got the Hyper B-Clock 2 engine, and so you can do base clock overclocking, which may actually result in better overclocks a lot of time than more multiplier. And with the Skylake X, we're also talking about things that can limit, you know, overclock ability. You need the negative multiplier for like AVX type instructions if you're running AVX workloads. These things support AVX 512 if you get the higher end CPUs. So it's a really interesting situation when it comes to overclocking. And so, you know, 13 phase power delivery system. Well, both sets of power phase delivery for both CPUs. Yes, that's true, but I don't think that the Skylake X CPU is going to use the Kaby Lake X power delivery system. So, that said, 7900X. We have a 7900X that was not cherry picked. It is a retail 7900X because that's just how we roll. And the 7900X that we have will hit 4.5 gigahertz on all cores with crazy amounts of cooling and crazy voltage. This motherboard delivered that, and it was fine, and it was stable, except for, you know, the CPU putting out more heat than the surface of the sun, which is a challenge in and of itself. But the motherboard delivered it. The VRM area did get quite warm. It does require active cooling, like pretty much every motherboard that we've seen in the X299 family. So I think that ASRock did a really good job just sort of nailing the line between not overbuilding the VRM solution and giving you something that you could reasonably expect. Because if you're shelling out $1,000 for a CPU, goodness gracious, you're going to want to squeeze every bit of performance out of that you possibly can. And this motherboard delivered that on our, you know, 7900X CPU. If you're running the 8-core, things are going to be a little easier on you on the 8-core side of things. But I think that I forget the voltage, but I remember doing some quick math and thinking, wow, we're delivering like 275 watts to the CPU in order to get this thing to be like 4.5 stable for all of the stuff that we're doing. Now, you can back off the voltage a little bit. You can do the AVX negative multiplier, and you can do some other stuff and get that wattage down around like 230, 240 watts, which is honestly very surprising. You think about it, it's like your run-of-the-mill 7900X going from 140 watt TDP to actually consuming, it's not exactly an apples to oranges comparison, but or it's not exactly an apples to apples comparison, but going from, you know, 140 watt thermal design power to actually dumping, you know, 220, 230, 250 watts into the CPU, that energy is going to heat one way or another. So that's a lot of energy to be dumping through silicon. It's a lot of energy to be dumping through that 2066 socket, but the motherboard delivered it, so there you go. Now, in terms of Linux testing and IOMMU, honestly, X299 right now, today, as of this video, is the better platform versus competing platforms if you want high core count and not insanely expensive, at least not as expensive as Xeon. You're willing to give up error correcting memory. You don't need error correcting memory in your application. The 8-core or the 10-core are both really good. I would not recommend the 6-core, even though that is a Skylake X part. I would also not recommend any of the Kaby Lake parts for those type workloads. IOMMU works great out of the box. The Taichi Uefi is basically the same as we've come to expect from ASRock, so no surprises there. Everything on Linux basically worked. Pass-through, all of that stuff basically works. It's still got some teething issues, you know, by comparison on the competing platform. It still has some teething issues on Ryzen and Threadripper. So if you're looking to build a monster system for virtualization and you want to do PCI Express pass-through, the X299 platform is the lower amount of headache right now. That's a kind of a developing story though, and if you want to follow along, you should subscribe to the Level 1 Linux channel where we're going to explore that and all that kind of thing. In terms of just monster, you know, multiprocessing, AMD's got a competing $1,000 CPU that'll give you better multiprocessing, and you can run more virtual machines and more virtual machines with some somewhat higher performance. But the 7900X is kind of a balance between single thread performance and applications that still need single thread performance, and you still get 10 cores. So yeah, it's $1,000, and yeah, it is gimped in weird ways, like the whole PCI Express lanes thing if you drop down to eight cores. But you know, if you're spending $1,000 on a CPU and your time's worth something, that may be worth something. Overall, this is a pretty solid motherboard. I've been pretty happy with it in testing. Only did about 72 hours of burn-in testing, so we've got some more testing to do. But if you pick up one of these and you want to share your experiences, please do so at the Level 1 text forums. I'm Wendell, I'm signing out, and I'll see you there. Oh, I almost forgot, a tour of the Uefi. Should this be in a separate video? I don't know, I think it messes with the Google Analytics, because it's like, oh, nobody wants to watch the Uefi. But if I were going to buy this board, it's like, oh my gosh, somebody posted a thing that has all of the screens in the Uefi. I would want to see that. So maybe I'll upload that as a separate video unlisted. I don't know. So if it's not immediately right now, it's in a link in the description. See ya.